In this video, we are going to study the path of a bottle rocket that is launched high into the air from the ground level. From ground level, that is the height zero. From zero all the way up, it is launched, and you are provided with a function, a quadratic function that is describing the height of the rocket at a different intervals. So t being the time, and h of t is the height of the rocket at that particular time. So I have a function here, I'm typing it in. H of t is equal to negative 20 t square plus 240 t. That's all. This is the quadratic function you have, and you're asked to explain about it, find the different things like in 1 second from zero in 1 second, what was its height? Say 2 seconds, what is the maximum height reached, and in how many seconds it came back to the ground, it touched the ground. That's all that we have to study from this. You have to get all these values by reading your graph that you're going to obtain now. So this is the function they give. You only have a function here, okay? So once I typed in the function, I got my graph, and you see that it is just a single red line I'm seeing that is telling me about this graph. And you need one more line, that is, it's a parabola, it goes up and comes down. And now I'm seeing on the x-axis, I can see at a 0 and also other x-intercept 12. So those are the two x-intercepts I'm seeing, right? So now we are done with x-axis. You got the time with this information. This is telling me that from the time the rocket released from the ground, going all the way up high into the air and to come down, it took 12 seconds. And that is your domain. You already got it. Okay. Then, what about the height, the maximum height that it reached? So by scrolling up, I'm going higher and higher. Nowhere it is closer, right? I'm not able to see where is my that height. So what we'll do is go to the settings on the right hand side top corner. Go to the graph settings, and so here in the graph settings, I have the x-axis. X-axis is the time in seconds, and y-axis, this we have to type it in. I already typed there in the setting. uh, on the x-axis you have the time in seconds, and on the y-axis it is the height. And the values for this x-axis, I'll just take -2 for our convenience on the left side for our graph to look better and also to have a clear picture. And the other x-intercept was 12, so I'll take 14 here, just 2 extra. And for the height, the minimum, like -50, I'll take it. As the numbers are so large there, I'll take -50. But y value, you see, here in the function you have -20 t square plus 240 t. That is the time. The time is, let us say, 4 or 5 seconds. Then it is 240 times 5. It is above 1000. And but there is a negative sign here, negative t square. So there is some reduction also. Just for our like trial kind of thing, let me type in 1000 and see what happens. I did say one more zero. So this is 1000. Just I took a random number 1000, and also steps of 50 I'll type in. -50 is the minimum, maximum 1000 I have, and this steps of 50. And now you have the whole of the graph in front of you. The height, the height reached by this rocket, the maximum height, and everything that is clear to you there now. And in fact, by having 1000 feet, you got a little bit extra. And as you can see now, the maximum height reached was 720 feet. So take a little bit more than 720, like 750 or 800 I'll have. Okay, to for our just convenience and for the graph to look better. And on the y negative also I'm taking 100, so that the bottom part also you can see little bit of the graph under your x-axis, right? So this is 800. Right? We decided, right? 800. We got steps of 50. That should be fine. Or you can have step of 100. That's okay. Intercept, second x-intercept, maximum value, and anything else that I can get from this. In the task, if you see, they asked what was the height reached in 3 seconds. In 3 seconds, what is the height? So that's the point. In 3 seconds you got, right? It is around how much? 544 something. I'll show you in a minute. And otherwise, using your calculator or manually, what you do, substitute t is equal to 3 here. So h of 3 is equal to negative 20 times 3 square plus 240 t. And I'll show you with the calculator also. I'm using this calculator. Let me turn it on. That is negative 20, start parenthesis. You're looking for 3, close parenthesis, and square plus 240 times 3. You can either use parenthesis or just times 3. It will give you how much? 540. Okay, 540 is the value in 3 seconds. The height of the rocket reached up to a height of 540. So likewise for each second, if you have to calculate using the calculator also, sometimes it's a longer process. Let me show you a shortcut. Go to this edit list and then convert this into a table. Now you have your values. You see at 0, 0. Negative values, negative time you don't have. So start from 0, 1, 2. In 2 seconds it reached 400. In 3 seconds, 540. That's what you saw here, right? And 4 seconds 640, coming down again. So likewise for all these, all the way up to your 12, you can get at 12, you see you got a 0. So everything is obtained here. All the information that is needed to answer the questions in your task are available here now. For example, like in 3 seconds, that was one thing. What is the maximum height? It reached a maximum height of 720 in 6 seconds. And then they'll ask you to find what is the rate of change. What is the rate of change from, let us say, 1 second to 3 seconds? So, how do you do that? In order to find the rate of change, you have to find the difference in y coordinates over the difference in x coordinates. This, the difference in the height at 3 seconds and the height at 1 second, right? So, let me use calculator here. Now, what is the difference in y coordinates? On the numerator, I'll type in 540 minus 220, right? That is the difference in your y values. The height change, the change in height is that much. And 3 minus 1, that is 2, right? The difference in the time is from 1 second to 3 seconds, it is 2. So I'll just divide that answer by 2 to give me 160. So the rate of change here is how much? 160 you got, all right? That's 160 feet per second. In 1 second, the height is increasing. On this side from 1 to 3, it went up by so much, 160 feet by second per second. And similarly, on the other side also, you can get these values like whatever rate of change from 8 to 10 or 8 to 9, etc. Okay, you can find those things. Not only that, and with reference to this rocket launch, you also have one question, I think, and you want to explode this rocket. That's after going high into there, it will explode and get all these sparkles and things like that. No, so at what height, for the safety of the people, you have to explode it at certain height. So they want to have it to maybe more than 500 or something like that. So how do you get the time interval? That is during what time the rocket is going to be in the air, that you need to know. So for that, another easier way I have here for you, you just type in one more function which says the height y is equal to 500. All right. This is here y is equal to 500. Now see this, I got a blue line here, a horizontal line, and this is the time. After 2.6 seconds, the height is going to be above 500 feet, and that rocket is going to be in the air more than 500 feet from this time 2.6 seconds all the way up to 9.3 seconds. So during that interval, anytime you can have that detonation or exploding the rocket can be done. Okay, this is another thing that you can answer from there. And next you have this, let us say the height of the rocket. What will be the height of the rocket, and what is the change that takes place in this function when instead of doing it from the ground, instead of sending or launching it into the air from the ground level, let us say the height from a height of 150 feet you launched. So what happened to the function now? What will happen to the given function? That the negative 20 meter height, instead of launching from the ground level 0, if it is launched from a height of, let us say, 150 feet, then what will happen to this function? It is no longer this negative 20t square plus 240t, but it got some height. So that height you have to add to it. Let me get that function here. Again, a new function, h of t is equal to negative 20t square plus 240t. And what's the height I said? It is now they added a height of 150. So now the graph, the scenario changed a little bit, not much, but now see what happened to the whole thing here. The maximum height, instead of this previous 720, now the height went up, added up for the 720, change it to 870 feet at the same time, and you can see the difference which is reflecting over there. Also, what I'm seeing here, also over here the settings, I'll go up here, I'll just change x value also went up now. You can see, yeah, it is little more than 12 and less than 13. I'll take 13 for x, and y I'll have 900. Okay, that's the only thing I will do here. This is 900, right? 900, this is negative 50, and x value 13 or 14 we had, I think. Okay, this is the one. Little upper area. Right, now what happened to the whole graph? It has gone up by 150 feet. You can see the difference all around. And also, now I can say that the initial height of the rocket, instead of 0, now the initial height is 150, and that 150 is the y-intercept, and everything else will be almost just the same. Those numbers have changed. Okay, I hope this will help you to finish up the task that you have. Okay, thank you. Thanks for watching.